All right, hello humans. This is section 6.6, which is solving exponential and logarithmic equations. There were a couple different ways you can do this, and I'll go through all of those different ways here. On number one here, you see that you have an exponential. Okay, so you can do one of two things. You can change it to a logarithm and try to solve it that way, but I don't recommend that. What I actually recommend is to see if you can write them as the same base. Because if you can write both sides with the same base, then you can set their exponents equal. Okay? And if you notice, you can write 16 as a base of 2. Okay, so we're going to keep this other side the same. Okay? And then you have to ask yourself, what power of 2 would get us to 16? And because you're so smart, you understand that that exponent is 4. Okay? Again, I haven't changed anything. I've just rewritten 16 as a base of 2. Okay? Now let's set the exponents equal, because if you remember when we learned in class that if the bases are the same, then the exponents have to be equal. Okay? Subtract 1, so 2x is equal to 3. Divide by 2, x is equal to 3 over 2. Boom, roasted, done. Don't think too hard. Okay? Number 2, now we've got a logarithm. Okay, and if you remember from class, I said when there's one logarithm, change it to an exponential and then solve. Okay, so we're going to use our acronym of BAE. Our base goes first, then our answer, and then what's left. Okay, 4 squared is 16. Now it's algebra 1 problem. 16 minus 4 is 12, and 12 divided by 3 is 4. Okay. Again, nothing life altering, shattering, or anything. Most of the time, you guys are good when you're looking at these individually, but then on the test, when I give you like several to do and you don't know which method to use, just do what makes sense. Okay? Do what makes sense. As long as you do it right, I'll follow your work. All right. Number 3, now we've got this E, Euler's number, factored in. Okay? It's an exponential, but if you notice here, you could write both sides as a common base. Here you cannot. You can't write E as a base of 6. You can't write 6 as a base of E. Okay? So this is when we had to use the inverse operations of a logarithm. Okay? And remember, you can use any logarithm that you want, but when you have E, you're going to use the natural log. Okay? So we've got the natural log of E to the x plus 1 equals the natural log of 6. Remember, you can do that as long as you do it to both sides. You can't just take the natural log of E of this side and then leave the other one. Okay? Not cool. Don't do that. All right, so then we learned that those cancel because they are the common base. So you're left with x plus 1 equals the natural log of 6. Okay? To get x by itself, you subtract 1, subtract 1. So now you're left with the natural log of 6 minus 1. That is not the natural log of 5. Okay, remember that this has to come first. If you want to put those in parentheses, you can. You have to take the natural log of 6 and then subtract 1. Okay? On your test, I would like this answer, not a decimal, if you could. It's just more exact, and I like it prettier. I like it better. It's prettier, okay? All right, I'm actually going to come down here and do number 5 first, all right? We talked in class about how when you have logarithms of the same base, you can set what the logarithms are equal to one another, okay, or what you're taking the log of, rather. Please do not say that you divide by the natural log. You cannot do that. The logarithm is a function, guys. Okay, you can't just it's like saying to me, okay, now you're going to take that and multiply it by, and then not finish your sentence. Okay, you can't just say divide by the log. The log of what? Okay, you have to, and I know that's a hard concept for some of you to grasp, but do not do this. Do not divide by ln. I will probably cry. Okay, but the idea is still the same. If you're taking the natural log on both sides, all you have to do is take what you're taking the log of and set them equal to one another. Okay? So subtract an x, you get 4x. Subtract 2, you get 8. So then x equals 2. Okay? Don't make it any more difficult than it has to be. As long as these are the same base, you are able to do that. If they're not the same base, then you have a problem. Okay? Fun fact. All right. Back on to number 4 now. The reason why this is different is because now we've got a plus sign and 2 logarithms and a 2 on the other side. Okay, so this is when we had to use the product property, and we can do that because both of these bases are 6. So we've got log base 6 of 6x times x minus 1 equals 2. Okay, and then we can take what's inside and make it to be 6x squared minus 6 equals 2. Now we've got something like we have up here. We can now use our acronym of BAE and do base, answer, and then whatever's left. Okay. So then 6 squared is 36. And then in order to solve a quadratic, everything has to go onto one side. So now we're left with 6x squared. Oh, that should have been an x. Sorry, 6x. There we go. Okay. Minus 6x. And then minus 36 equals 0. And then you could solve it like that or plug it into your graphing calculator at this point. I don't really care. But I'm going to divide everything by 6 just to make my life easier, make my number smaller. Okay. And then to continue factoring or continue solving, I'm going to factor to there. So that means that x can either be 3 or x can be negative 2. Now here's where you cannot just circle both answers and be done with it. You have to go back and plug those numbers in to make sure that they're not going to create a negative number inside of a logarithm. In other words, okay, if you plug in 3 to that x, 6 times 3 is 18. Okay, so we're fine. If you plug in 3 to this x, 3 minus 1 is 2, so that's okay. If we plug in negative 2 right here, we're going to get, okay, you're going to get negative 12, the log base 6 of negative 12. And remember, you cannot take the log of a number of a negative number. It does not exist. That was one of the questions on your test. Okay, so make sure that if you ever have an answer that gives you a negative number, it is extraneous, and you need to tell me that somehow. Either cross it out or write the word extraneous. I don't really care. Just figure it out. Okay, that's really the only difficult part about this entire section is just recognizing, okay, does my answer actually work? So don't forget to do that. Okay, that's pretty much the only cases that you're going to see. If something pops up, let me know. But other than that, thanks for watching.